Hi there, this is Soman and you're watching the Genesis YouTube channel. Today we will see a question which I have named the free fall pulley system version 1. Why version 1? We'll be seeing more versions of this question as I introduce rotational elements into it. So without further ado, let us look at the question. A system consists of two blocks attached to inextensible light strings through three pulleys as shown in the figure. All the pulleys are light and neglect friction at all contacts. If required, take the masses of the pulleys as M1 and M2 respectively and the masses of the blocks to be MA and MB. For modeling the pulleys, take M1 tending to 0 and M2 tending to 0. Find accelerations of the pulleys P1 and P2 and also that of the blocks A and B. These are the hint figures that appeared in the problem video. I hope you have given it a good try. So let's go on to the solution now. Now, first thing to understand is that as there is no friction between the strings and the pulleys don't rotate and the strings slide over them. This is critical and this is exactly the point which I'm going to change in the version 2. Now, the free body diagram of the systems is shown in this figure. I have chosen downwards positive. I have chosen all accelerations downwards. If you are worried with this choice of all positive downward accelerations, don't worry, if any acceleration is upward, it will come out negative. Now looking at pulley P1, we can see that the force equation will be 2T plus M1G minus T is equal to M1 into A1. Now for pulley P2. For pulley P2, it will be M2G minus 2T is equal to M2 into A2. Similarly, for block A, MAG minus T is equal to MA into AA. And finally, for block B, we get MBG minus T is equal to MB into AB. Now focus on the free body diagram of pulley P1. From the force equations, we can say that A1 will be equal to T plus M1G by M1. Now, if M1 tends to 0, A1 becomes infinite if T is not equal to 0. Therefore, the only physically meaningful solution for the system corresponds to T is equal to 0. The same result you will get if you consider the free body diagram of pulley 2 and make M2 tends to 0. Now what does this imply? This implies that if the tension is 0, the blocks A and B free fall. So acceleration of A and acceleration of B is G downwards. Now how do we calculate the acceleration of the pulleys? To calculate the acceleration of the pulleys, we need to consider the string constraints as well. It is given in the question that the string is inextensible. Here you can see the system after a small time interval dt. Now if I focus on the blue string, you can see that the blue string is pulled down dxb and the pulley comes down by dx2. dxb increases it, dx2 decreases it. So we write plus dxb minus dx2 is equal to 0. Why is equal to 0? Because the length of the string cannot change. So that is first constraint. Now look at the green string. That full string which is going from A to P1 back to P2 and then going back from the top pulley to P1. Now look at the segment of the string between the pulley P1 and A. You can see that dxa increases its length and dx1 decreases its length. So the corresponding term is going to be dxa minus dxb. Now come to the segment of the string between P1 and P2. You can see that dx2 increases its length and dx1 decreases its length. So the corresponding term is dx2 minus dx1. Now we come to the segment of the string between pulley P2 and the top pulley. And you can see it is only dx2 which is increasing its length. So the corresponding term is plus dx2. And finally, the portion of the string between the top pulley and P1, you can see that the corresponding term is going to be plus dx1. Adding all this up, we say it is equal to 0 because the change in length in this string also will be 0. This gives us two constraints. So now we have two constraints. Plus dxb minus dx2 is equal to 0. Divide both sides by dt. Note I am not differentiating it. Divide both sides by dt. You will immediately get v2 is equal to vb. And now we had this constraint dxa minus dx1 plus dx2 minus dx1 plus dx2 plus dx1 is equal to 0. Cancel out the dx1 and divide by dt. You will get va plus 2 times v2 is equal to v1. So we have our two constraints. Now taking these two equations As V2 is equal to VB, differentiate this, you will get A2 is equal to AB, and AB, remember, was G downwards. So A2 is G downwards. So the pulley P2 has an acceleration G downwards. Second constraint is VA plus 2V2 is equal to V1. So differentiate this, you will be getting AA plus 2A2 is equal to A1. Now the value of acceleration of A is G downwards. For A2 we found it is also G downwards. So A1 is 3G downwards. Hence what is the result? A and B, the blocks, fall with acceleration G downwards, also has the same acceleration, and the pulley 2 also has the same acceleration and it falls with G downwards. Whereas the pulley P1, this falls with 3G acceleration downwards. Now you might be worried, if everything is accelerating downwards, won't the length of the string increase? No, think carefully. P1 pulley has an acceleration of 3G and the distance between P1 and P2 will decrease much more rapidly. Try to visualize this and try to see that there will come an instant when P1 will essentially collide with P2. So will this system continue indefinitely? No. If it is a finite length system, if there is a finite length of string between P1 and P2, yes, they will ultimately collide. But in the question, lengths were not mentioned to you. That means we are considering it over a time interval in which this kind of a situation has not happened. In the version 2 of this question, I'll be introducing friction between the pulley and the string. I'll be introducing moment of inertia of the pulleys, and we'll be seeing how the situation becomes different and how close it becomes to real life situations. So I hope you enjoyed this problem. If you learned something from it, like, share and subscribe. And as always, stay safe and stay healthy you all.